Hello there, Mr. Sutton here, bringing you the Algebra 2 Chapter 1 Quiz Review Solutions on Linear Functions. For this first problem, we're trying to graph this function. This is a transformation of the absolute value function. So let's start by writing the parent table for absolute value. So this is going to be, there's any points you could choose, but I prefer the points from -1 to +1. So that's -1, 1. 0, 0, and 1, 1. These are the easiest points to plug in. And what is my transformation here doing? Since I'm adding 5 inside changes are left-right changes, and they're inverse of what you expect. So adding 5 inside is actually shifting us to the left by 5. So when I write my rule, g of x, I'm doing x minus 5. That's how I'm changing my x values. And then y doesn't change at all. Now, if this 5 had been added outside the absolute value, then it would be an up-down change and it would be exactly what it looked like. So that would have been +5. But we were inside. So changing my x values, -1 minus 5 is -6. 0 minus 5 is -5. And 1 minus 5 is -4. The y values don't change at all, so we still have 1, 0, and 1. All right, getting a xy axis here. I notice I've got this -6 going on, so I'm going to make my axis all the way over here, so I've left myself some room to plot this. So I've got -6, 1 right here, and then we've got -5, 0, and up here we've got -4, 1. And then just draw the absolute value curve through those points. For this problem, we're trying to write a function whose graph represents the indicated transformation of this f function. So we're taking 4x minus 3 and performing a horizontal stretch by a factor of 5. So since this is a horizontal move here, this is going to happen inside the function, and it's going to be inverse of what it looks like. So instead of multiplying by 5, I'm actually going to multiply by 1 over 5, the reciprocal of 5. And I'm going to do that by x inside the function. So I'm going to first write this as f of 1/5 x. And then I'm just going to apply this f function to the input of 1/5 x. So I'm going to write 4 parentheses 1/5 x minus 3, which I could simplify if I wanted to 4/5 x minus 3. On this one, we're trying to transform the f of x function using all these transformations and write a new function based off of that. So the key on these is to take it one transformation at a time and just build a new rule for each individual transformation. So I'm going to first write a g function that does only one thing to the f function. I'm going to translate this up 6 units. So I'm going to rewrite this as g of x equals f of x plus 6. F of x, not h of x. There we go. So f of x plus 6. It's an up-down change, so it happens outside, and it's what it looks like. So this whole thing is just going to have 6 added to it, which just gives us 1/2 absolute value of x plus 4, and then plus 3. So it's good to simplify as we go. All right, next I'm going to perform a translation 2 units to the right. So I'm going to create an h function that shifts the g function 2 units right. Since that's an inside change, it's going to be opposite of what it looks like. So we've got h of x equaling g of x minus 2, not plus 2. So now I'm going to take all this stuff over here that was my g function, and I'm just going to replace x with x minus 2. And that's it. Now I can simplify this a bit. -2 and +4 gives me a plus 2 inside that absolute value. So again, simplify as we go, makes our life a little easier. And then the final transformation is a reflection in the y-axis. To achieve this, I need to negate the input. So because this is the y-axis, it's a left-right change, so this is going to be an inside negation change. So I'm going to write a j function that basically just does h of -x. That's going to give us that left-right reflection. And then that's going to just take all of this stuff and replace the x with a -x. And that's it. For this problem, we're just using this graph to write the equation of the line. So let's see here. It looks like we've got a point at 0, 0, and also a point at 3, 165. So my slope formula is just asking how much am I going up divided by how much am I going over. Rise over run. So we've got 165 up and 3 over. So there's our slope. And we could do 165 minus 0 and 3 minus 0, but 0, 0, I mean, you don't really have to show that piece of it unless it's something other than 0. So let's just simplify this now. That's going to come out to 55. And then the y-intercept, if I can find it, would be good, because then I can just use y equals mx plus b form. The y-intercept is just 0. It's where we touch the y-axis. So using y equals mx plus b, I can just write this as y equals 55x. I don't have to write the plus 0. On this problem, we have two shops renting kayaks for a rental fee plus a fee per hour. The table down here shows the fee for the different number of hours for shop A, and then the total cost for shop B is shown by this y equals 7x plus 9 equation. We want to know, based on these two different representations, which shop charges less per hour. So if we're asking for the per hour, we're basically asking for the slope of whatever this function is. So for the table here, we can figure out the slope by just using our slope formula, y2 minus y1 over x2 minus x1. So that's going to be 23 minus 14 over 2 minus 1. So that's just 9 over 1, or just 9. Now the slope for shop B is just the m in this y equals mx plus b form of the equation that they gave us. So it's just going to be 7 for them. So we could pick that one right out of the equation. So interpreting this in a real-life context, that means that the hourly charge for shop A is just going to be $9 per hour, and for B we've got $7 per hour. So between the two of those, shop B is charging less per hour. On this problem, we have a table showing number of absences in a school year and the final exam scores for a number of students. They want us to use technology, so basically Desmos, to find the line of best fit for this data set and use it to predict the final exam score if a student only has one absence. How well would that student do? All right, so we're going to go to Desmos. And on Desmos, we're going to go to the plus here and select Table. And then I'm just going to enter all the x and y values into the table. So for example, we've got 3, 6, 0, and so on and so forth. And then we'll enter the y values, 83, 68, 98. I'm going to do all these off camera just so I don't have to keep tabbing back and forth. All right, so we're back. I've entered all of the table data into Desmos. Next up, I'm going to go to this, there we go, magnifying glass with a plus in it called Zoom Fit. If I click on that, it gives me a nice window on the data that I just entered. And then I'm going to scroll back up here to where I can see this little regression line, Add Regression button. Let me press that, and that gives me my regression line of best fit through here. If I scroll down a little bit, then I've got my equation for that line. Negative 5.098, if I round it off, x plus 98.261. So here's what I've got. Here was the thing I just saw on my graph. Here was my equation. And now if I want to actually use this to predict the exam score for a student with one absence, I just have to plug 1 into this. So I'm going to go back to Desmos, and I'm going to be a little sneaky and click this equation button that exports my equation to the next entry line here. Now instead of calling this y equals, I'm going to rename it to f of x. That just gives me a way to plug things into the function. So now I can just do f of 1 absence, and that comes out to roughly 93 for the score on that exam. For this one, I need to solve this 3-variable, 3-equation linear system using, they said elimination method, but really any method you want is fine. So let me start by labeling these, and this would be a good one for elimination method because we have no letters missing anywhere, so substitution would be a little trickier here. So I've labeled these E1, E2, E3, and my basic strategy, if I'm using elimination, is just going to be to add these in a way that cancels out variables. So I have to start by first figuring out what would be the easiest variables to cancel out. Now normally I would say y because we've got one y here, And that's pretty easy to turn into all these other things, but these x's also look pretty tempting, right? These are all multiples of 3. So I'm going to try to get rid of the x's first. To do that, if I multiply this first equation by negative 3, that would give me a positive 9x that would cancel out with this negative 9x in equation 2. So that's what my first step will be. We'll do negative 3 times e1 and then add that to e2. So going through and distributing that, we have 9x minus 9y minus 21z equals negative 3. And then for e2, we'll just cut and paste that. Now if I add these equations together, the x's cancel. Negative 9y plus 8y is negative 1y. Negative 21z and 5z is negative 16z. And then this will add up to negative 13. All right, I'm going to call this equation 4, and I'll use it later. I need another equation like this, though, that only has a y and a z in it. So to get that, I'm going to do something now with equation 3, which I haven't really addressed yet. So I'm going to use equation 1 again, but this time instead of multiplying it by negative 3, I'm going to multiply it by negative 2 and then add it to equation 3. Because if I do that, as you see here, we'll get positive 6x for that first term, and that's going to cancel out with this negative 6x. But I have to make sure I hit the rest of those terms as well. So we've got negative 6y, minus 14z, and minus 2. So copying and pasting equation 3 over here, adding these together, we've got the x's canceling as predicted, and then this is going to be negative 5y, and then minus 10z equals 5. And I'll call that equation 5. So I'm trying to now combine equations 4 and 5 in a way that gets rid of one more variable. What would be the easiest variable to get rid of? I'm thinking the y's would be pretty easy. If I just multiply equation 4 by negative 5, that gives me a positive 5y, which will cancel this negative 5y. So let me do that. Negative 5 e4 plus e5. So this gives us, again, 5y plus 80z equals, I think this is, what, 65? Yep. And then cut and paste equation 5. So if I add these, the y's now cancel. We've got 70z equals 70. Well, that's mighty convenient. Dividing by 70, we just get z equals 1. And now I just have to plug 1 into one of these equations that only has 2 variables, and I can figure out the value of y. Let me just go with the first equation, e4. So we'll have negative y minus 16 times 1 that we just found equals negative 13. So this is really just negative 16. Adding it over here, I get positive 3, but negative y still equals that. So then positive y equals negative 3. And finally, last but not least, I need to get the value of x. I can get that if I plug 1 and negative 3 in for z and y in really any of these equations, but I'm going to go with equation 1 right here. So we've got negative 3x plus 3 times negative 3 for y plus 7 times 1 equals 1. So this is going to be negative 9 plus 7, which is negative 2 over on the left side. If I simplify that, add that over to the right side, we've got 3. And then dividing by negative 3, we have x equals negative 1. So just to write my answer as a point now, we've got negative 1, comma, negative 3, comma, positive 1.